Hello, I'm Ray, G4NSJ. Right, Flowerpot antennas. I've already made a video about how to make one. I made a separate video about how they work. So what I've done, it's all a bit of a mess all over YouTube. What I've done is put video bits together. So it explains, first of all, hopefully how the thing works and then how to make one. I keep referring to an article by Steve Hunt, which is so good. I'm going to put a link below this YouTube video to his page. His Steve Hunt G4NSJ. He's written an article and it is fantastic. It made it so clear for me of how this aerial works. People say, oh, a flowerpot antenna, you know, in a piece of plastic conduit. It's an end-fed dipole. Other people say, no, it's not. It's a centre-fed dipole. Other people say, no, it's not. It's a quarter wave ground plane. I think, and you'll see why I think this, it's a centre-fed dipole. Let's have a look at, first of all, about what Steve says about coax. This really does explain it, for me at least, perfectly. Have a look at this. Now, he says here, you think of coax as a two-core line, don't you? You've got the inner and the outer, all right? So it's two conductors, isn't it? He says here, coax cable is, in fact, a three-conductor line. The third and independent conductor is the outside surface of the braid. Now you're thinking, how can it be a three-conductor line? There's inner and outer, there's only two. As he explains in his article, and I do urge you to have a look, I'll put a link at the bottom of the video, down there, look, I'll put a link. Have a look at it and read it. Some time ago, I decided to build a flowerpot antenna, a so-called half-wave coaxial dipole. And people said to me, oh, it's not a dipole, it's a badly designed quarter-wave ground plane aerial. Other people said, no, it's an end-fed half-wave dipole. It's not, it's a centre-fed half-wave dipole. Now already you're thinking, some people thinking, no, it's not, no, you're talking rubbish. Read this article. Let me just explain what this chap says. When you pump RF up that, there's what you call the skin effect. So the RF travels on the outside. There's the inner conductor, right? The centre core travels on the outside of that, all right? The braid, there's the inner core in the middle, there's the braid. It travels on the inner surface of that braid in there, okay? That's the two conductors that we know about, right? It doesn't go through the braid to the outside. This is what he says, and he explains it very well. The third conductor is the outer surface of the braid. This is hard to grasp for anyone who is new to RF engineering. But the skin effect is a dependable fact, and so are all its consequences. So it's a fact. So don't shoot me, I'm the messenger. This, understanding that, all right, as he says also, you can put this through water, you can put it through metal, you can coil it up. You can do what you like with coax. Put it through a metal bulkhead or whatever. It doesn't have any effect on what's going on inside. Okay, that inside, as he's put somewhere, is like a private world, right? The inner of the braid and the inner surface of the braid and the surface of the inner conductor. That's where all the RF is. That's where you're sending a signal. What happens on the surface of the braid outside is totally different. Right, we're going to have a quick look at the blackboard now. The article says that the RF comes up here. Right? This is a quarter wave. So if we cut the coax there, we're putting RF up here, say from our 2 metre radio. That's a quarter wave, so that will radiate, won't it? It's a quarter wave radiator. This is the braid here. Okay, so that's sticking out of the centre there. The RF is on the outside of that one, and the inside here, okay, not the outside. When you cut it off here, this comes out, it spills out onto the outside. Okay, so you've got RF on the outside of that, and now on the outside of the braid here. Doesn't affect what's going on the inside. Do you see that? When I read this, it all started to make sense. I always thought this was the case anyway, and other people just poo-pooed it. Ah, that's rubbish. They came up with various ideas about this aerial, but this makes sense. That's the quarter wave. The outer surface of the braid is a quarter wave. This is the sort of choke thing. Okay, so it all stops there. All right, that's the idea of that. So there is the lower quarter wave of your dipole, there is the top quarter wave of your dipole, and it is fed in the middle. It's a centre fed half wave dipole. Now, if you want to argue with that, don't argue with me, because I'm not an RF engineer, never have been and never will be, because I'm not clever enough. But this, to me, makes all the sense in the world. I can now get to grips with exactly what a Flowerpot or coaxial dipole is. Right, let's take an HF dipole, right? There it is, HF dipole for whatever, let's say 40 metres. There's your coax. I mean, you don't normally have plugs on it. There's your coax going up to the centre of it. So it's a 40 metre dipole. It'll only work on 40 metres because you fed it with coax. If you want to feed it with open line feeder, it'll work on other frequencies and things. Right, that goes up. No choke, no balance, no stuff, no gubbins, right? Inner to one bit of the dipole, outer to the other bit of the dipole. What's going to happen? You're going to get these two elements of the dipole are radiating, aren't they? They're putting your signal out and you're working DX. Excellent. But what else is going to happen? RF will go up the inner surface of the braid and spill out over here. It'll spill out and come down here, down the outer surface of the braid. So you've got a leg there of the dipole and a leg there of the dipole, and now a leg here of the dipole. You know, with a dipole, there's a centre dipole. What you want is the current peaking in the middle, isn't it? Like that. That's the current. Voltage that end, voltage that end. High current in the middle, because that's just the bit that radiates. Okay. If you've got this radiating, it can totally mess up that pattern. So you've got to somehow stop the outer here becoming part of the aerial. It ends up, as Steve says in his article, you end up, it's not a dipole, it's a tripole, as he's put it, which is very good, I like that. You end up with a weird sort of tripole effort that is not efficient at all. So that's where this comes in. Now, coiling this all round a toroid, right, doesn't affect what's going on inside, because someone recently said to me, if you do that and this greatly attenuates, say 2 to 30 megs, really attenuates everything, you know, like 30, 40 dB or more, well, you've lost your signal, surely. You know, the station you're trying to listen to, you've attenuated his signal by kind of 40 dB. No, because inside is like the private world. What's happening outside here doesn't affect that at all. So that whizzes round as it would do, unaffected by the outside. What this does, it affects the outer surface of the braid. So that presents a very high impedance, perhaps a couple of thousand ohms or more, to any RF that's on the outside here. So it can't, there's your aerial, there's your dipole, right? That is a really high impedance to any RF on the outside. So that is stopped there, and then down here, what's that? We're getting noises. Okay, do you see what I mean by that? I'm not very good at explaining this because, as I said earlier, I'm not an RF engineer. And also, even if I did understand the real in-depth mathematics and technicalities of all this, I don't think you'd want to hear that, because I know a lot of you are newcomers, you're starting out, you know, you don't want me to go on about square roots, that whatever they are, I don't know, square roots of something or other, flowers. Flowerpot, yeah, Flowerpot antennas probably have square roots, don't they? Anyway, moving on. So that's what that does. It basically takes RF off the outside of the coax, because you're going to have it where this is cut, the coax is cut to feed each leg of the dipole. It's going to, as I said, on the flowerpot antenna, it's going to spill over there and come back down the outside to make a tripole. Okay, that's how it works. That's my understanding of it, and I reckon that Steve Hunt is right. Everything he says, as I said, it makes sense to me. Right now, here's the video clip of how to make a flowerpot dipole. This one I'm making for the aircraft band. I've got a scanner here that I use just on the aircraft band. I don't know why I listen to that, because it's extremely boring. Anyway, this is how to make a flowerpot antenna. You need a piece of conduit. A bit long, this one. You need a bit of conduit. This is 20mm conduit. In one of my videos, some chap said this bloke spent the first 7 minutes waffling on about stuff before he actually got down to the whatever it was I was doing. Well, I was trying to explain things. I like to try to explain things because we're not all, we're not all experienced in everything. There are some people that are just starting out and they're just learning. So anyway, you want a piece of this. I've got a 2 metre length, dirt cheap. So what you do is, let's put that to one side. First of all, you get some coax. Now, I'm making this aerial for the aircraft band. So I've centered it on 123 megahertz. Because what is the aircraft band? It's about 109 to 139 or something. So 123 megs is about the middle. So that'll do. Now bear in mind I'm not transmitting. I mean, you can transmit on this area. I'll go into that later. So you look up on the internet, there's a calculator. A flowerpot or coaxial dipole calculator. You type in the frequency you want, 123 megs, and it'll come up when I've written it down. 54 centimeters for the top of the dipole, 54 centimeters for the bottom part, and then 87 meters. That'd be a bit long, wouldn't it? 87 centimeters for the coil. I'll go into that in a minute. So get a piece of coax and strip off, not you, the coax, 54 centimeters of that. Okay, take the outer sheath off. Cut off that as well, which will be the same length, of course, and you will end up, here's the picture, you'll end up with that. Right, now what you want to do is get your conduit and measure from there down. Well, you want 254, so that's 108 centimeters. Measure down and make a hole big enough to put your coax in there. All right, so your dipole, there's the bottom section, there's the top section, will fit in there. Must get my hair cut. The hairdresser bloke's closed. What we're going to do is thread the coax through into that hole, okay, all the way up here until, can you see, hang on, can you see, there it is, I've already done this, there it is, just poking out the top there, just leave a little bit there. What some people suggest is tie a fishing line around that, then bring the line here and put a plastic cap on. If this was going outside, you want to waterproof that with a plastic cap on there. So you've poked that all the way through your hole, all the way up here, so you've got your coax in there, and that will be the two 54 centimetre lengths, 108 centimetres. Now, where the coax comes out, there's a picture. You see that, where it comes out? Just put a little bit of tape around there to secure it for a minute, otherwise it'll be moving around all over the place. You then want to measure from, you've got the coax coming out of the hole, haven't you? You've just taped it. Measure 87 centimetres. This is for the airband one that I'm making. I've also made a 2 metre one for the amateur band. I transmit on that. I've made a marine band one. Well, they're all up in the loft. They work really well. So you've got that. You've got the coax sticking out of the hole here with a bit of tape. Just measure 87 centimetres. Put a bit of tape round it. Measure it. Just put a bit of tape so you know where it is. And then you're going to wind that amount up to your tape around the pole. Now there's a photo there. You see what I've done? Wind it around the pole. Now we're not counting the amount of turns. The good thing about this online calculator is it gives you the length that you need to wind onto your pole. the pole might be a different diameter. You know, the one I'm using is 20mm. If you're using a slightly thicker one and you're going by the number of turns, it's not going to be right. So go by the length, which is good. So you now end up with your coax in there, a little bit on the top there. You've got your coil wrapped round there, and then the rest of the coax just hanging off. What I've done, you can see in this photo, what I've done is tape it all up just to secure everything. What I normally do, I've run out. I put over that centre section, I can show you on this one now, over here I put heat shrink sleeving like that, right? Give that a quick blast with a hot air gun, so it keeps all that in place, and it waterproofs it. If you want to put this outside, that's ideal. And then put the plastic cap on top, of course, and basically that is it. That is the aerial. Now this coil is it's a choke. It's an RF choke. So you've got your dipole here, right? This is the feed. You don't want RF going past this and all back down the coax, or you don't want this acting as part of your receive aerial, which is this going to be receiving. So that chokes off any RF. That's all that does. And that's it. What I mean, this is rather long. What I'll probably do is cut it off about there, just leave enough so I can mount that on the top of an aluminium pole, or I'm just going to stand it in the loft, or you can hang it up in the loft, up in the attic, hang it up there. And they work extremely well. They really do work well. So if you're making one you're going to use for transmitting as well, like my 2-meter one, some people say to get the SWR right, take a turn off or add a turn to the coil. I've never done that. I always leave that little bit sticking out of the top of the pole, make it slightly too long, so I can just trim that off to get the SWR right down. Bear in mind, as with any aerial, don't lean it up against something metal, a metal window frame or a metal set of drawers or something, in your workshop. Have it out in the clear, because that will muck up the SWR. So take it out into the clear if you can. Get the SWR right there, and then stick it up on your pole. If you're putting it in the loft, don't put it somewhere clear of other metal objects. If you've got pipes up there or house wiring and stuff, just try and keep it on its own. For receive, as I say, I made a marine one which is up there. This is the aircraft one, which is going up there in a minute. It's not, the SWR doesn't matter. And you can make this aerial for any, well, within reason, any frequency you want. You could use it up on UHF. It's obviously going to be a lot smaller. The other way, if you use it, for example, on the 10-meter amateur band, it's going to be pretty long. Bear in mind, it's going to get longer and longer as you go lower and lower in frequency. But it'll still work, if you get the measurements right, of course. So that's basically it. 54 centimeters on the inner bit, 54 centimeters on the shield to the hole, 87 centimeters coiled around. Tape it all up, whatever, shove it in the loft, stick it outside, stick it up somewhere, and off you go. Job done. You can, if you want to, where the coax comes out, goes around and around, you can make another hole and put it back in. So the only part of the coax outside the conduit is the coil. Poke it back in again. I don't bother to do that because these are just going in the loft. I wouldn't mind actually this aircraft one. I've got it going now, and I am listening to various aircraft on it, and it's just propped up against the window here. I wouldn't mind trying it outside at some stage. I don't know why it's so dark in here. It's a bit weird. I've got lighting on all over the place. Anyway, as I said, I must get a haircut. I hope that has helped, because I've had a lot of emails and messages, about, oh, this is wrong, you're wrong with this and that. Other people are saying, that's right, but I don't understand this and that. I mean, I don't understand all of it. When I make these videos, I'm not getting everything from my brain, right? I'm getting everything from information I've put together. I look on the internet, I look in books, I ask people. I think that's the best way to do it. I've never been afraid to ask people. If I don't know how something works, I'll ask someone who knows how it works, rather than pretend I know how it works, because that doesn't help anyone. That's the blind leading the blind, as they say. Anyway, waffling now. Look, just bought a little frequency counter. Look, that's another issue. Thanks for watching. I shall see you next time. Take care. Bye bye for now.